Okay, I started this recording a little bit late. We're finding the determinants. Finding the determinants. This is lesson 2-5. Okay, basically, you guys, a 2x2 determinant is just a square matrice. I mean, a 2x2 matrice where you multiply the diagonals 4 times 8 and then 3 times 1 and you subtract them. Okay, so we got 4 times 8 is 32, 3 times 1 is 3, and we got 29. And here's the formula for it down here. We're going to go A1 times B2 subtract A2 times B1. And that is the formula you'll need for the determinant. Okay. Next one. Actually, I'm going to do this. I'm going to give you a couple more. Everybody, find the value of this determinant right here. Going to give you 30 seconds. When you got it, everybody compare it with each other at your table. Oh, by the way, yeah, you guys, the symbols for determinants are straight signs, kind of like absolute value signs. Okay. Another way to do it is we can write the abbreviation of determinant right there and then put the brackets like we do. So if you have vertical lines around it, that means find the determinant. Or you can write it like this, determinant of the matrix 0, 8, negative 5, 9. These two things mean the same thing. Yeah, we're going to be doing it by a 3x3 in just a second. Yeah, even if it's negative. Well, what do you mean? The second part? 0 times 9 minus, right? Negative 5 times 8. Well, if I multiply this out, 0 times 9 is 0. A negative times a negative, or minusing a negative is the same thing as a positive, right? 5 times 8 is 40. So the answer is 40. If one of these numbers is negative, negative 5 times 8 is negative 40, you're minusing a negative number, right? Which is the same thing as adding. So you're always going to get that. Okay, let's do another one. Yeah, this means the same thing right here. If I put vertical lines around this square array of numbers, it means find the determinant. Or you can write it DET with the brackets around it. It means the same thing. So this and this mean exactly the same thing. Any questions on that? So on your test, I'm going to put vertical lines around it, or I'm going to do this, and you have to know what that's asking you to do, because I'm not going to write above it, find the determinant. You should know that vertical lines mean find the determinant. Or brackets with the word DET in front of it means find the determinant. Okay? Everybody got that? That's the symbol for finding the determinant. Okay? Because if I just have vertical lines and don't write anything else, you know that's the determinant. Okay, here we go. Next one. Find the determinant of this one. Okay, compare it with everybody in your group. Okay, this is what you should have done. 7 times negative 8 is a negative 56. And then I'm going to minus 2 times 3, which is 6. If I minus 50, if I have a negative 56 and I minus 6, that gives me a negative 62. Okay, we got it? Okay, now, how do you find a determinant of a 3x3 matrix? We're going to use a method called expansion of minors. Okay? Everybody write this down. Expansion of minors for finding a 3 by 3 matrix. This is kind of a longer process. Okay. Here's the method right here. What you have to do is choose any row or column. Choose any row or column. Which row or column would you guys like to choose? Top row. Okay. Let's choose this top row. Okay, so this is the numbers we're going to use. Now, what we're going to do is we're going to take and we're going to go 3, which is the first element, and times it by a determinant. And then it's just, this is the way it goes. Minus 1 times another determinant plus 5 times another determinant. Okay? So do you see we took these three numbers, 3, 1, and 5, out of the row we chose? And you're going to go 3 times a certain determinant. I'll tell you what that determinant is in a second. Minus the 1. The second one's always going to be minus, just so you know. So if it was a negative number, it would be plus, right? And then the determinant plus the 5 and another determinant. Well, the question is what goes in as the determinant? Kyle? Yeah. For 3, everything that's not in its row or column. So if we crossed out this row and this column, what's left? 6, 2, 4, 9. So we're going to go 6, 2, 4, 9. By the way, there's proofs on why this works. I'm not taking the time to show them to you right now. There's some information in your book if you'd like to look at those. Okay? Then I go to the 1. I'm going to cross out every row, the column and row that 1 is in, okay? 1 is in this row, and it's in this column. So what's left? 7, 2, 8, 9. 7, 2, 8, 9. I go by rows when I read them. 7, 2, 8, 9. And then you go to 5. What's not in the same row or column as 5? 7, 6, 8, 4. So now, what it's telling me to do is times 3 by this 2 by 2 determinant, minus 1 times this 2 by 2 determinant, plus 5 times this 2 by 2 determinant. So we have to find out the determinants of each of those. There's different methods, but that's if you take linear algebra in college, they will teach you that. So it's kind of a similar process, but not quite the same. Okay, it's a long process, a really long process. Okay, so we got to find these 2 by 2 matrices. So what we're going to do is I'm going to go 6 times 2. So I'm going to go 3. And what's 6 times 9? 54 minus 4 times 2 is 8. Okay, that's the first one. Minus the 1 times, just watch this right now, you guys. And then I'll give you a second to write it down. Okay? And I'm going to find this one. 7 times 9 is 63 minus 8 times 2 is 16. Right? So we've got that so far. Plus 5 times 7 times 4 is 28 minus 8 times 6 is 48. Now I just have to simplify this. Remember, addition and subtraction first inside the parentheses. So 54 minus 8, 46. So 3 times 46. And then 63 minus 16 is what? 47. So minus 1 times 47 plus What's 28 minus 48? Negative what? Negative 20. So 5 times negative 20. So I'm going to go 3 times 46, which is it 138? 3 times 45 is 135. So add 3, it's 138. Minus 1 times 47 is 47. And yeah, because it's minus 1 times 47. 5 times negative 20 is a negative 80, or negative 100. So minus 100. So 138 minus 47 minus 100, negative 9 is your answer. So all that boils down to negative 9. That's the determinant. You guys think you can do a problem like that? Okay, I'm going to give you guys a second to write this down. I'm going to give you about 3 minutes. 3 minutes to do this. Go. Okay, so the answer is negative 121. Okay, good job, you guys. Okay, now, we've got to use this to help us find inverses. Now, all eyes right here. Okay. Do you remember what an inverse is, first of all? Okay, let me go forward a little bit right here. Let's say we're going to solve the equation 2x equals 4. Everybody knows what you're going to do to get x by itself and to solve it, right? What are you going to do? Okay, the other way to think about it is to multiply by 1/2, the reciprocal, right? Or what we call the multiplicative identity. Because when I times 1/2 by 2, these cancel out and I get 1x, 1 times x, right? 1 times x is just x. And over here, 4 times 1/2 is 2. Or in other words, half of 4 is 2. Okay, and we get this right here. Okay, 1/2, you guys, is what we call the multiplicative, multiplicative inverse of 2. Okay, so 1/2 is the multiplicative inverse of 2. Write that down in your notes. I want you to write that equation down, 2x equals 4. To solve that equation, we multiply both sides by the multiplicative inverse. Multiplicative inverse. 1/2 is a multiplicative inverse of 2. That's because when we times 1/2 by 2, what number do we get? 1/2 times 2 is 1. And multiplicative inverse is the number you times by something to get 1. So 1/2 is a multiplicative inverse of 2. Okay, now let's find the multiplicative inverse of 2/3. When you know, raise your hand. Don't say it out loud. When you know the multiplicative inverse of 2/3, raise your hand. Now think about it. It's the number I got to times 2/3 by so that I get 1. What is the multiplicative inverse of 2/3? Raise your hand when you know. My word. Only a couple people. Miranda, what do you think? 3/2. 3/2 is the multiplicative inverse because those will cancel out to make 1. 3 will go into 3. And 1 times 1 is 1, right? It's just the reciprocal of the number, right? That's called the multiplicative inverse. That's what we use when we're solving equations. So going back to right here, how do you find an inverse of a 2 by 2 matrix? Well, to find the inverse, you have to find the multiplicative inverse by doing this right here. This is how you do it. Everybody write this part right here down. This is the formula for finding a multiplicative inverse. A1, B1, A2, B2 is equal to 1 over the determinant You guys notice that A1 B2 minus A2 B1 is the determinant? Multiplied by switching a couple of these elements around. We can do a proof of it. It's in your book. You're welcome to look at it. I'm just going to teach you how to do it today. This is a formula for finding the multiplicative inverse. Write this in your notes. You'll want to put this on your 3x5 card. Formula for finding the multiplicative inverse. That is the formula for finding the multiplicative inverse. It looks all complicated. It's really not that bad. You got it down, Kyle? If you think you know how to do it, try example 1. Did you already do example 1? You did both of them already? Nice job. Kyle's already done both these problems right here, found the multiplicative inverses. Okay? Sometimes formulas look complicated, and they're really not that bad. We got to find the inverse of this matrix 2, 4, 1, 3. Okay, I'm going to show you number 1 here, the first one, and then I'm going to let you guys do the second one on your own. Okay, are we ready? You guys want to try it on your own? Okay. We'll just follow the pattern. What's A1 B2 minus A2 B2? What is that? A1 times B2 minus A2 times B1. Isn't that just the determinant? You've been finding determinants all day today, right? And notice right here, all we did is switch B2 and A1 around, and then made these two negatives. I'm going to do the first one with you. You guys are going to do the second one. Here we go. We're going to go 1 divided by the determinant. 2 times 3 is 6. 1 times 4 is 4. I'm going to minus that. So what's 1 over 6 minus 4? It's 1/2. So I'm going to put an arrow instead of a, this is an arrow, okay? So, well, this one's an equal sign because we got an equal, okay? So 1/2, okay? 1/2 is what we get when we find the determinant. We go 1 over divided by the determinant. I am going to multiply that by, notice A1 and B2. What did we do with B2 and A1 right here? Here's A1, here's B2. Over here, it's B2 up here and A1 right here. What did we do? We switched them, right? So I'm going to take 2 and 3, and what am I going to do with them? I'm going to switch them. Here's 3, here's 2. That's all the formula's doing. Okay, yeah, when we're done. And then notice right here, B1's here, but now it's an opposite of B1. And A2's here, and now it's the opposite of A2. So what's the opposite of 4? Negative 4. What's the opposite of 1? Negative 1. And now there's my determinant. There's my inverse, except for we have a scalar times by it. We're going to times 1/2 by that. If I times 1/2 by 3, I get 3/2, right? 1/2 of negative 4 is negative 2. 1/2 times negative 1 is negative 1/2. And 1/2 of 2 is 1. This right here, you guys, is my inverse. That's how you find an inverse. That's my multiplicative inverse for this matrix. At all? You must not have been listening because it's real easy.
No, I don't get why you have the 3 over 2 and then negative 1 over 2.
What's 1/2 times 3? What happens when you times a fraction by a whole number? 1/2 times 3 is the same thing as 1/2 times 3 over 1, right? You multiply the top together. 1 times 3 is 3. You multiply the bottom together. 2 times 1 is 2. And you get 3/2. You guys don't know your fractions, some of you. You guys got to know your fractions. You You guys, teachers in the past let you use calculators too much. There are certain things you want to use calculators for, but certain things you guys need to be able to know how to do. Okay.
So negative or a half times negative 1 would be negative 1/2.
Yeah, because you're going to go 1 times negative 1 is negative 1 over 2. 1/2 times 2 is you're going to go 1 times 2 is 2 over 2. 2 over 2 is 1. Or you can just think of taking half the number. The odd numbers, when we take half the numbers, I leave them as the odd number over 2, right? But the even numbers, I can divide the bottom 2 into that number, right? Taking half of it. Kyle. Is it all right if you use decimals instead of fractions? I'd rather you guys use fractions right here. You guys got to know how to do your fractions. Okay, everybody, in your groups, find the inverse of 6, 4, 7, 5. I'm going to give you a few minutes. Go. Okay, so your answer on that last problem, I should go back real quick here. Your answer on this problem, okay, well, I'll just kind of do it real fast. Okay, 6 times 5 is 30, and 4 times 7 is 28. 30 minus 28 is 2, so it's 1 over 2. My determinant was 2, right? Okay, I'm going to times that. I got to switch the 6 and the 5. So the 5 goes up here, the 6 down here. I don't switch the 7 and 4. Some of you guys switch the 7 and 4. You don't switch them, you just make them negative, the opposite. So negative 4 and negative 7, right? And then you just times the 1/2 by them. 1/2 of 5 is 5 halves. I know some of you guys put 2.5. I mean, in the long run, that's going to be okay, but I just think you guys need to understand fractions too. 1/2 of negative 4, 1/2 times negative 4 is negative 2. 1/2 of negative 7 is negative 7 halves. And 1/2 of 6 is 3. So that's my answer right there. Got it? Okay, now we're going to go down and use what we know about inverses to help us solve a system of equations. You guys have learned, last year you learned elimination, substitution, and by graphing. Now we're going to use matrices to solve a system of equations. Okay, so what we do is, first of all, we set up two matrices. We set up this matrix right here, 2, 3, 1, negative 1. Where did I get those numbers from, you guys? Huh?
2's over 1.
Yeah.
Where do you look?
I shouldn't write like that. We're gonna. Okay. We shouldn't write it like that. Okay. We are going to take. Well, we're going to take and make 2, 3, 1, and negative 1. That's a matrix we're going to take. And where did I get that from?
I don't know.
Yeah, the 2x, 3x, 1x, and negative 1y. Or 2x, 3y, 1x, and negative 1y. That's where I got those numbers from. I am going to find hold on just a second. Okay, guys, this is how you set up a matrix equation for a system of equations and two variables. Okay, think about this. This is a 2 by 2 matrix, and I'm timesing it by a what?
Where do you get that? X, the Y,
The x and the y are the variables.
all right.
I want you to see, and this is a what? What size matrix is this, you guys? The x, y? Because we can. Because we can.
So dumb.
I'll show you why in just a second, but just watch, okay? Because we can. Sometimes we do things because we can. Okay? All right. So, and this is a 2 by 1 matrix, right? Now remember, when you guys times two matrices, is it possible to times this matrix by this matrix? Yeah, because the two middle numbers are the same. Number of columns in this one is the same as the number of rows in that one. What's my resulting matrix going to be? A 2 by 1, right? which is what the resulting is. Think about this, you guys. If I take this row and times it by this column, I'd be times the 2 times x and the 3 times y, which is the 2x plus 3y, right? And that's equal to negative 17. And down here, if I take this row and times it by this column, I'd times 1 times x and negative 1 times y, which would give me 1x minus 1y equals that element right there, 4. That's how the multiplication works. Do you see that? Now, so since we know that this is possible, I know to solve this matrix equation, I would multiply both sides of this by the multiplicative inverse. Now, if we call this matrix A, and we call this X to represent the variable matrix, and we take this and we call this matrix B right here, what I'm going to do is I'm going to take the inverse of A and times it by A, okay, times by times by X, a matrix equation, and that's going to be equal to, we're going to do the same thing the other side. We're going to take the inverse of A and times it by matrix B. So all I'm doing is I'm taking the A times X equals B, because that's what that is. You guys see that? A times X equals B. And I am going to multiply both sides by the multiplicative inverse. Remember that equation I showed you guys a little bit ago? 2x plus 4? 2x equals 4? What did we do to both sides of this equation, you guys? We times both sides by what? 1/2. That's the same thing we're doing here. We're multiplying both sides by the multiplicative inverse. So we've got to find the multiplicative inverse so we can multiply both sides by it. We're almost out of time. But if I found the multiplicative inverse and I times it by this size, it would give me what's called the identity matrix. You guys, the identity matrix is this. Okay? Everybody write this down. This is the identity matrix. It's like 1 in real numbers. It's called the identity matrix. Write that down. It's called the identity matrix. If you multiply the identity matrix by this, if you multiply the multiplicative inverse by A, take the multiplicative inverse of A and times it by A, you'll get the identity matrix, and when you times it by xy, you'll just get xy, right? And when you times the multiplicative inverse by that, you'll get the solutions. So guess what? Since we're out of time, I'm going to show you how to do it on the calculator. You guys ready? Well, you don't know enough about it to make that determination. Eddie, hey, whenever something gets hard, you can't call it stupid. Hey, you guys, I'm going to tell you right now, whenever something gets hard, you can't call it stupid. I'm going to show you why it's valuable. Here we go. Hey, remember how we've been solving systems of equations? Hey, watch this. Everybody, go to your matrices on your calculator, quickly. I'm going to show you why it's not pointless. It's a fast way to solve systems of equations. What are you going to do in life? You going to work at McDonald's and flip hamburgers? Okay, then you might need it. Okay, here we go. 2, enter, 2, enter. Everybody make a 2 by 2 matrix and put in that matrix right there. 2, 3, 1, and negative 1. Okay, any questions on that? 2, 3, 1, and negative 1. We put in this matrix right here. 2, 3, 1, and negative 1. Okay, now go to second matrix again and go to B. Oh, wait, sorry. Okay, I don't know why. Go to matrix, go to second matrix again and go to edit and go to matrix B. And what size of matrix is this one over here? 2 by 1. So make it 2, enter, 1, enter. And put in negative 17, and 4. Okay, there's my other matrix. Go to your main screen. And we're going to do A inverse times B. So everybody ready? Hit second and matrix. And you're going to bring up matrix A. And see this x to the negative 1 button? That's A inverse. And then you're going to hit times. And then you're going to go get matrix B. And you're going to hit enter. And there's the solution to this system of equations. Negative 1, negative 5. That's a little bit faster than the other way you learned, right? Yeah, what's stupid now? Come on. What's pointless now? Come on, bring it on. Come on, Clayne. Come on. Huh? Okay. Come on. All right. Hey, that's just another way. You guys, sometimes math just has another way of doing things. And it's good to understand your math completely. Okay. Hey, you guys, here's your assignment. We do. That's your assignment, lesson 2-5, page 102. 14 through 44 evens. Now, listen. I would do all the inverses and determinants you can by hand. And then I'll let you have a little bit of time, and I'll let you do the solving the systems of equations using the calculator next time we're here on your assignment. I'll give you some time to finish this up. Now, Friday, be here on time because we have a short class. Class is only 40 minutes long, 45 minutes long, I think. 45 minutes long, okay?